Hello friends, in the last video I have shared with you some of the preliminaries for the Turing machine, in which we discussed about there are two types of languages we have discussed. One of them is called as a regular language and another language is called as a context free language. Now here there are some machines which recognizes the regular language, and the machine is called as finite automata, and there are different versions of finite automata. There is a deterministic finite automata, there is a non-deterministic finite automata, there is a NF null, and all things we have already discussed in this for these languages. Then we got another set of languages which are called as context free languages, and these are some special languages wherein we need to remember the contents. For example, the language of palindromes, let us say. So in a language of palindromes, what you have to do is you have to compare the first symbol with the last symbol, compare the second symbol with the second last symbol, compare the third symbol with the third last symbol, and compare the fourth symbol with the fourth last symbol. Or if it is a odd length string, in that case you need not compare it. So for this purpose, what we did is we had a abstract machine in which we used a stack, and then we inserted the first half of the symbol. For the odd length string, we didn't did any operations, we just read it and we left it out. And then for the second half, what we did is we compared the next element with the top of the stack. If they are equal, then it is matched and go for comparing the next one. So B is compared, A is compared, and finally if the stack is empty and all the complete string is read, at that time we can say that it is a palindrome. So for this we had a machine which was called as push down automata, that we have discussed already. Then the next abstract machine we have to discuss is the Turing machine. Let us have a small discussion on what are the previous machines that we have discussed. First machine is called as finite automata, and I say that finite automata is so whatever that string you want to identify, the languages could be all the strings which ends with A, and let us say something like this. So here there is nothing to remember, so whatever the number of states are there, that states will take care of remembering and all the things. For example, this is ending with A means you need to remember the last symbol. So if A comes, then you are at the acceptance stage. After that, any number of A's comes, you are at the acceptance, and so on. I hope all of you know this one already. Then we had a push down automata, and what happened with this push down automata is initially for a given state and for a given input, we checked out what is the top of the stack, and we updated the top of the stack and we had a move. So delta for the PDA is Q cross summation union null string cross stack symbol to Q cross stack symbol. So we are updating the stack symbol, whereas for finite automata it is Q cross summation. So for a state and for an input you take a new state, or it could be the same state, any member from the given set of states. So let us try to define what is a Turing machine. So a Turing machine, so as we have previously discussed about the two machines, similarly, so for the finite automata it is a 5 tuple, for a what you can say push down automata it is 7 tuple. So let us define a abstract machine. So again, here we are going to have a machine, we are going to define it as a machine. So let us define a Turing machine. Now many of the books, John Martin, he is defining a Turing machine. The different books can be, you can find out different books with different definitions. John Martin says that a Turing machine is a 5 tuple. So what are the 5 tuples? It is Q summation lambda is this symbol, so I am pronouncing it as a lambda symbol, then Q naught and delta. So there are 5 tuples in a Turing machine. What is Q? As in case of finite automata, in case of push down automata, here also Q is a set of states. Now here in a Turing machine, along with the Q, it is considered as that there are 2 more states. Now a set of states, Q is a set of states, and there are 2 more states. They are called as HA and HR. So if your Turing machine finally enters to the HA is acceptance state. So if it enters to the HA, it means that your string is accepted, whatever the operation you want to do is accepted. If it enters to the HR, once it enters to the HR, it will not come out of the HR, and this is called as a reject state. This is you can say comparable with the invalid state of the finite automata. So in the finite automata we had a state which is called as invalid state. So it is compared this reject state and acceptance state, and there are some other set of states. We have summation. Now this summation is a set of input symbols to the Turing machine. Then lambda, or you can say gamma, is a tape symbols, set of tape symbols. Now these tape symbols, so you can say that all the input symbols are the subset of tape symbol, and along with that there are some more symbols that can be inserted on the tape. I will discuss on what is this tape and all. This is for the gamma, or I am pronouncing it as a lambda. Then we have another state, another tuple, that is called as a Q0, and it is the initial state as usual. So in case of finite automata as well as in case of push down automata, we had this initial state, so from where the automata starts. And delta in case of finite automata was this one, and it is called as a transition function. This is the transition function for the push down automata. So push down automata, and you can say, so we already had the discussion on this. So let me show you, like this one is a delta for push down automata, and this one is a delta for finite automata. All of you know already this one. So now let me define about what is the delta here. Now here the delta is partial function. I say that this delta is a partial function. Now this delta is defined as, in a Turing machine, the delta is defined as Q cross lambda union so there is another delta. So this is another delta I am saying. This is mathematically we have another delta symbol. So lambda union delta, it takes the transition to this Q cross lambda union delta, it take a transition to Q union. So from we have the transition from state Q to Q union. Either along with this any Q, we may move to either HA or HR. We can either move to any state or HA or HR. Cross lambda union delta. So we are going to update the tape, and along with that we are going to have a move either right or left or remain static. So this is a partial function. This is a partial function. This is called as a partial function of the Turing machine. In my another video I will try to share about this tape and all. So this is about the definition of the Turing machine.